let phi of n be the Euler's phi function. In this video, I'm going to find phi of 7, phi of 9, phi of 15, phi of 88, and phi of 264. So we need to find those values there. So I'll start by looking at the Euler's phi function. The Euler's phi function of a prime, phi of p is equals to p minus 1, where the p there is a prime. And if we have p being a prime, then phi of p to the power r is equals to p to the power r minus 1 multiplied by p minus 1, where r there is a positive integer. And the next one, I'll look at the multiplicative property of the Euler's phi function. Phi of m times n is equals to phi of m times phi of n if the greatest common divisor of m and n is equals to 1 and m and n are positive integers. And then for the next property, if we have the prime decomposition of the number n being equals to p1 to the power alpha 1 multiplied by p2 to the power alpha 2 up to pr to the power alpha r, where those p's are distinct primes, then phi of n is equals to n multiplied by the product from I equals to 1 up to r of 1 minus 1 divided by pi. So I'm going to use these properties there that I have listed to answer the questions which are above. So I'll start by looking at the first one there, phi of 7. When you are looking at the phi of 7 there, the 7 is a prime number. So I can use this property here where we have the phi of a prime number is equals to the prime number minus 1. So in this case, we'd have phi of 7 will give us the 7 minus 1, which is a 6. I will now move on to the second one there, phi of 9. In this case, the 9 there is not a prime number. So what we can do is we try to find the prime factorization of 9. So I save my phi of 9. The prime factorization of 9, it will be 3 squared. So we'll be having phi of 3 squared. So when it is of that form, we can use this property here. So we'll be having that our p there is a 3, our r is a 2. So we'd have phi of 3 squared will be equals to 3 to the power 2 minus 1 times 3 minus 1. And that will give us 3 times 2, which gives us a 6. I will now move on to the next one there, phi of 15. Phi of 15 again is not the form of a prime. So let us look at the prime factorization of 15. So I'll write my phi of 15 there. For the prime factorization of 15, that's 3 times 5. So we have a phi of 15 is equals to phi of 3 times 5. And to evaluate that, we can use the multiplicative property there. Phi of m times n is equals to phi of m times phi of n. Just because we are having the 3 and the 5 there, they are relatively prime. So what we would have there is phi of 3 times 5 is equals to phi of 3 times phi of 5. The 3 and the 5, they are prime numbers. So we can use this property here. Phi of p is equals to p minus 1. Since we are having the prime numbers. So for the phi of 3, it will be 3 minus 1, which gives us a 2. For phi of 5, it will be 5 minus 1, which gives us a 4. So what we would have there is 2 times 4, which gives us an 8. I will now move on to the next one there, phi of 88. Phi of 88, we are not having a prime there, so let us try to have the prime factorization of 88. And we would have the 88 there is 2 to the power 3 times 11. So we would have phi of 2 to the power 3 times 11. What we are having there is the prime decomposition of 88 is 2 to the power 3 times 11. So we can try to use this property there, which is at the bottom there. Because we are having 2 distinct primes, 2 and 11. The 2 is raised to the power 3. So we'll be having our alpha 1. Will be equal to 3, and for the 11 is just raised to the power 1, so our alpha 2 will be a 1, and our n we are saying is this 88. So using this formula there, phi of n we'll be having there is equals to the 88 multiplied by the product from I equals to 1 up to R. We are saying our R, the two distinct primes, there are two of them. So we'll just be having two products. So it will be 1 minus 1 divided by the first prime multiplied by 1 minus 1 divided by the second prime number. And when you simplify that, it will give us a 40. So we have phi of 88 is 40. And now I go on to the next one there, phi of 264. For the 264, its prime decomposition there, we can write it as phi of 2 to the power 3 times 3 times 11. So in this case, we can use the one which is at the bottom there. We are having three distinct primes, the 2, the 3, and the 11. So we'll be having 2 to the power 3. So we'll be having our alpha 1 will be 3. And then 3 is just to the power 1. So our alpha 2 is a 1. 11 is just 11 to the power 1. So it would have our alpha 3 is equals to a 1. So we're having three distinct primes there. So using this formula phi of n, our n is the 264. So we'd have 264 multiplied by 1 minus 1 divided by the first prime, then multiplied by 1 minus 1 divided by the second prime, multiplied by 1 minus 1 divided by the third prime number, the 11. And when you simplify that, we get an 80. So what we are having there is phi of 7 is equal to 6, phi of 9 is equal to 6, phi of 15 is equal to 8, phi of 88 is equal to 40, phi of 264 is equal to 80.